All right, hello. So sorry about the cutoff at the very end of that video. Not really that important. I was just kind of babbling about how before when we did interpretations, like they were supposed to be really interpretable to pretty much anyone, but now when we have to do this odds interpretation, it's still like not that interpretable, I guess. Like, I don't know, if you read this to someone who's never had this class, they might not know what this multiplicative change means. They might not really know what odds are and all that. So anyway, now that we've kind of covered inference, if we have a quantitative predictor, now we're going to talk about, okay, well, what if we have a categorical predictor? And in particular, we're going to start including shot type, which we introduced in the beginning of this note packet. And so why might this be useful? Well, this would be useful if different shot types, they might have different probabilities of scoring. Even for a fixed distance. And so if that's true, then we would want to include shot type in our model. If for a fixed distance, these different probabilities have, or these different shot types have a different probability of scoring. How we do that in R, that's pretty simple, as you might guess. Just like we did before, we add it to our model. I'm just now noticing I have distance in here twice. And it looks like by default R just assumes that you don't want one of them because it still only fits a model with distance. Good job, R. How smart of you. So once we add type into our model, we see that we get 6 more coefficients because remember there's 7 categories of shot type, and so one of them is the reference group. And so in this case, if you go back to where shot type was defined, our reference group is backhand shots. So remember, R likes to do things alphabetically. So the reference group by default is the first level of the categorical variable alphabetically. Okay, and so let's go ahead and interpret one of these coefficients in context of the problem. In particular, let's interpret the coefficient for deflected of 1.034. And so if I take e to the 1.034, if you plug that into R, you would get 2.81. And the interpretation is going to be super similar to when we interpreted a coefficient for a categorical variable before, except now that we have distance, we've got to include it in the interpretation. So I want to say for a fixed distance, we estimate that the odds of a shot going into the goal are 2.81-fold more for a deflected shot compared to a backhand shot. So it looks like our model is estimating that the odds of a deflected shot going into the goal are higher than the odds of a backhand shot going into the goal. How much higher? 2.81 times higher for the deflected shot than for the backhand shot. So we could also answer one hypothesis test question, whether or not distance is associated with whether or not the shot goes into the goal after accounting for the effects of type. And so I'm grabbing this tiny p-value here and saying yes. Our p-value is 2.883 times 10 to the minus 10. So there is very strong evidence of this. What we can't answer yet is a question about whether type is associated with whether or not the shot goes into the goal after accounting for the effects of distance. And so we can't answer this yet because you might make the connection that sounds kind of similar to a nested f-test when we have to test all of these at the same time. The corresponding test in logistic regression isn't called a nested f-test, but it operates pretty similarly. And so we'll talk about that next, as well as kind of the analogous thing to the overall f-test that we used in multiple regression as well.